Okay, everybody, 12-part series. We're getting halfway into it, talking about the blue gene. Check us out. We've got great products. We have wonderful stud dogs. We've got lots and lots of Frenchie stud dogs. We do a huge amount of this. We produce lots of really beautiful puppies from our stud dogs. So if you have a Frenchie that needs a stud, we've got a mate for you. And we've got tons and tons of different colors. Okay, so here we go. The blue gene. The blue gene. That is the dilution gene. It's kind of a little bit, it's not really blue. It's the dilution gene. And that's why the moniker for that is little d, little d. It's a recessive gene. You have to have 2 copies of the recessive gene to produce a blue dog. Well, what is the dilution gene? It is a gene that affects the color that's already there. So if you've got a brindle dog, and it's also little d, we call that a blue brindle. And what happens is the black that's part of the brindling gets washed out to this bluish color. And so that's why it looks blue. If you have a non-brindle dog, like basically a fawn dog, and you introduce blue to it, then it becomes a blue fawn. So it washes out the fawn, and you will see this kind of hueish blue to it. If you've got a dog that is an AT, tan-pointed dog, or an ATA dog, and you put blue with that, then you end up with a blue and tan. It's a blue and tan. And the tan points show up on the legs, on the face, on the back of its rump. You'll see tan points. And the tan points will look slightly different. This will be more of an orange look to it, more of an orange tan point. This is more of a cream color to it. And if you also have a dog that also has 1 copy of cream, it makes this even brighter. It makes the tan point show up even more. Incidentally, if you had a dog that is actually a cream dog, then the cream trumps everything, and that ends up being a cream covered in blue. You can't even see the blue. All right. So popular color, been a popular color for a long time. Again, we're talking now about exotic colors. All of you show ring people don't like any of this stuff. We understand that, but the fact is that these dogs are sought after dogs. And I'll see people who make comments like, "Oh, people are asking ridiculous colors for blue dogs for a gene that shouldn't even be there." Well, look, it is there, and they're rarer, and because of that, supply and demand. They demand more, they get a higher value. For whatever reason that is, it's all economics. And if you don't like blue dogs, then absolutely don't buy a blue dog. All right, so let's do some Punnett squares on blue to see how this works out. So, wipe this off a little bit. Right, so remember with blue, you've got to have two genes present for it to be expressed. So it has to, for its phenotype, for its physical appearance to be blue, you have to have 2 copies of the blue recessive gene present. All right, Punnett square time. And I'm running into this problem where I've got a wet board. So we'll just take a towel here. Otherwise, these colors are not going to show up worth a diddly. Wipe these off a little bit. All right, that'll work. Okay, so there's our Punnett square. All right, so how do you get a blue dog? Well, you put a blue dog with a blue dog. Anybody want to guess what the outcome is? You get 100% blue offspring. All the dogs are blue. Okay, take one of these dogs, and we'll do it the conventional way, which would be the dominant gene first. That dog is not a blue dog. Its genotype is blue. It has a blue gene present. But since it's a recessive gene, you have to have 2 copies. That is not a blue dog. Not blue. That dog does not look blue. There'll be nothing about that dog that you can look at to say, hey, that's a blue carrier dog. The only way you know it's a blue carrier dog is you either did a genetic test on it, or you know that it had a blue parent. Okay. What do you get when you put these 2 dogs together? Well, you get half the dogs that are blue carriers and half the dogs are blue. So you can put a blue dog with a non-blue dog and get blue puppies out of it. So some people are surprised at this, but there's nothing surprising at all when you realize how the genetics work. Let's go one step further Let's put this dog with another blue. This again is not a blue dog. It's not blue. This dog does not look blue, but it has a blue gene buried in it. Its genotype is a blue carrier. Its phenotype is a not blue dog. What do you get? Well, you get that. That's what you get. So, non-blue, 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 1/4 of the litter. Blue, 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 1/4 of the litter. Big D, little d, big D, little d, blue carriers. So you get one dog that will never produce blue puppies. You get 1/4 of the litter, excuse me, 1/2 of the litter that are blue carriers, and 1/4 of the litter end up being blue. So you can have 2 totally non-blue dogs, and from that you can get blue dogs. So let's just go one step further on this, and let's make this dog a totally non-blue dog mated to a completely blue dog. So we've got a blue dog on this side, and we've got a totally non-blue dog on that side. What do we get? We get all the dogs. Every single dog in that litter is a blue carrier. None of the dogs show blue. All of the dogs are blue carriers. And that's interesting because, you know, there's some things that you can do down the road. If you get a puppy from a litter where you know one of the parents was blue and the puppy does not look blue, you know that dog has to be that. You don't have to test for it. If that puppy that you bought came from one of the parents was a blue, you know that you have to have a puppy that's capable of producing blue puppies itself, although it's not blue. If you bought a puppy from a mating of 2 blue carriers and your dog doesn't look blue, what is it? You don't know. It could be a blue carrier, it could be a totally non-blue dog. You don't know without testing. So I see people making these mistakes where they'll say, oh yeah, both dogs are blue carriers, your dog has to carry blue. No. Good chance, there's a good chance it carries blue, but it's certainly a 50% chance in fact that it carries blue, but it's not guaranteed by any stretch of the imagination. And the only way that you can find out if that dog does carry blue is either you do a genetic test for it, or you breed that back to a blue dog and you get blue puppies out of it, and then you know it had to have carried the copy of blue. Okay. Last thing, blues come in different variations. There are different versions of blue. There's blue fawns, and that is decided by any dog that's little d is going to be blue. But you can get blue fawns. You can get like silver blues, and you can get dark blues. And any variation in between is quite possible. And these things are determined by other genes, like what's on the A locus, will determine what these other colors are. So if you see, sometimes it can be confusing, especially with things like silver blues, because they can look like they might be a lilac dog. So people can get confused. You know, you've got a dog that looks really silvery blue and somebody says, oh, it's a lilac dog. Well, we'll talk more about that when we get down here in a bit to talk about lilacs. But the answer is, you've got to be careful. You've got to know the genetics of the parents and a bit of other information to find out whether truly you either have a silver dog or you have a blue dog. Very pretty, by the way, silver blues. Okay, that's it on the blues. We're rocking along. So that's blue out of the way. So now we are halfway through the whole series. I'm getting there. Time for a cup of coffee for me, and then I'll start back up again. We'd really like it if you went to look at our stuff. We've got wonderful things for incubators and whelping kits that are, you know, unique. Nobody else has them. Some of these products are patented by us because we've invented these products. We'd really like to take a look, and we'd love you to subscribe to us because that does help us, you know, make us want to do more of these videos. Hey, thanks for watching. Bye, everybody.